Good morning to you all. Myself Shreya, and today we are going to learn about the sorting of materials according to solubility. Now what do you mean by solubility? So for understanding this, let's do a very interesting experiment, or you can say an activity. So here I have a glass of water along with a spoon, and here I have some salt. So now what I am going to do is that I am going to mix some of the salt, or I am going to just mix some of the salt into this water. So now let's do this. So let me open this, and here let's mix it, as you can see. So I am just mixing it with the help of the spoon. So now let's mix it a little and let's stir it and see what happens. So here, as you can see, can you see a very interesting thing here? Where is the salt? Are you able to see any salt here? No. What? The salt is disappeared? Okay, now let's do the same thing with some rice grains. So here I have some rice grains, as you can see. So now let's do the same with the rice grains. So I have another glass of water, and now let's mix some of the rice grains in it. So here I'm just mixing this. Let's see what is going to happen. Okay, it is not mixing. It is not disappearing. What? So, salt is disappearing in the water when I mix it with the water, and the rice grains is not disappearing in water. Why is it? So that's the solubility. We can say that the salt is soluble in water. Now, we have seen that the salt dissolve in water. What do you mean by dissolve? Yes, just mixing fully mixing. Like that, we had seen that the salt is disappeared. So we can say that the salt is dissolved in the water, or the salt is soluble in the water. And as we had seen that the rice, as you can see, let me bring these both the glasses here. So as you can see that the salt is fully disappeared, and we can see it, so it is dissolved in water. And here we can see the rice grains very easily, and they are just not disappeared. So because of that, we can say that the rice grains are insoluble in water, or the rice grains can't dissolve in water. So we had seen this. Now, before moving on, let's learn 3 new words. And I think that you had already learned these words in the lower grades. So now let's just revise it. They are solvent. Let me change my marker. Yes, solvent, solute, and solution. So, can you see something very interesting? These names are basically a little rhyming, isn't it? So, solvent, solute, and solution. What do we mean by these? Let's start with the solvent. So, for understanding this, let's take a very interesting example. So, have you ever seen your mother making a lemonade? It is very fun to drink the lemonade in summer. So if you have seen your mother making a lemonade, what does she do? She takes a glass of water and in it she mixes some salt and of course the lemon juice. After some time, when she mixes that and stir that solution, basically that is the solution. When she do that, what happens? The salt and the lemon juice get disappeared, like the salt we had seen here also how it gets disappeared. Now in this case the solvent is the water. Now what do you mean by solvent? The solvent is a medium in which solute get dissolved and forms a solution. So what is a solvent? When anything gets dissolved in something, here in this case water, so when something like a sugar, salt or lemon juice, when it gets dissolved in the water, so we can say that water is the solvent in this case. And the rest of the thing which is dissolving in the water, that is the salt, sugar or the lemon juice, these all are called as solute. What about the solution? Solution is the thing which we get at the last. That means that here we had mixed salt in it. Let me keep this marker. Yes. So we had mixed salt in it and we had mixed the salt in the water. So water here is the solvent. Solute is the salt. What about the solution? What is the name for this solution? Of course, the salt solution. If there will be sugar, so we will say it as sugar solution. So we had got a salt solution. So that simply means that solvent plus solute gives us a solution. So I hope that it is clear. Now, do you think that all liquids dissolve with the liquid or all the liquid mixes completely with the liquid? Let's check this with a very interesting example. So again, I have another glass of water and in this I am going to mix oil. So now let's mix the oil and let's see that if it dissolves in water like the lemon juice or not. So here, as you can see, I have some oil. This oil. So now let's just pour this oil in this. So here, can you see this very interesting thing is happening? So I just fully mixed this. Oh wow! What is happening? This oil is making a layer on the water, or we can say that this oil is floating on the water. Why it is happening? It is not dissolving in water. We can see it very clearly. Now, this proves that not all the liquids mixes with liquids completely. So, always remember that oils doesn't mix with the water. As you can see, they are lighter than water and that's why they are floating. If they will be heavier than water and they doesn't mix with the water, so they will be at the down and at the down they will form the layer. So I think it's clear, as you can see. So here the oil is forming a very visible layer on the water, or it is floating also. Now what if we mix it with the spoon? So now let's take it. So here I have a spoon and now let's just mix it. So here, can you see it? I'm just going to mix it. Now is the salt dissolved in this water? Of course not. We can see it. It is seen like crystals. It is very interesting to see this experiment. Now can you see that again the oil is not dissolving in the water. So now, what about the gases? Does all the gases dissolve in the water? No, of course not. There are so many gases which doesn't dissolve in the water. And at the other hand, there are so many gases which dissolve in water. So now let's just list them out. So here, I'm just going to make a table. Here I'm going to make a table. Like this. Yes, so now let's just fill out the names. So here I am going to write the soluble substances, soluble in water of course, and here the insoluble substances. And we are going to list them out. So here we will write about the solid, about the liquid, and about the gases also. So now let's write down. So we have seen in the solids that the salt dissolve in the water, or the salt is soluble in water. So that means, as we know that the salt is a solid, so we will fill it. So salt. What about the insoluble substance? Yes, we had seen that the rice grain doesn't dissolve in water. So the rice grain is the insoluble solid. It is a solid of course. So rice grains. Now what about the liquid? You know, the lemonade, and in the lemonade we mixes the lemon juice. In that lemon juice is nothing but a liquid which dissolves in water, or it is soluble in water. So that means here let's take the lemon juice. And what's next? Yes, the liquid which doesn't dissolve in water, and that is oil. So oil doesn't dissolve in water and it floats on water. So oil. What about the gases? So you will see that there are so many gases which dissolves in water, right? Like the oxygen, the carbon dioxide. Now how we can see that the oxygen is in the water? And can we get any example? At least one? Yes. Do you know about the aquatic animals? They also breathe like us. Not like us, their respiratory system is very different from us, but they do take the oxygen and give out the carbon dioxide. Or even all the organisms take in oxygen and give out the carbon dioxide. And what about the aquatic animals? Now they are inside the water, so how do they breathe? Because the oxygen is dissolved in water oxygen is also soluble in water. So let's write oxygen here. And what about the insoluble gas? Do you know anyone? I think you of course know this. Methane and nitrogen, along with so many gases, they are insoluble in water. So now let's write this. So let's write nitrogen here. So I think that it's pretty clear to you. Let me write the spelling of the nitrogen more neatly. Nitrogen. Yes. So I hope this is clear to you. Let me just recap these all. Salt is the solid which is soluble in water. Rice grains are insoluble in water. And do you know that the chalk powder is also insoluble in water? Yes, it is. Now what about the lemon juice? It is the liquid which is soluble in water. And do you know that there is one more, ink. Now you will say that when we pour just a drop of ink in the water, the ink, we can see the ink, right? That water becomes blue. Now here we need to define the solubility. It's not the solubility. The liquids which are soluble in water, the water can change its color. Okay, according to that liquid, the water can change its color. But that liquid, there is one condition for the liquid to be called as dissolved in water. So there is one condition, that it should mix completely. There is no need that the water should remain into its own color. It can change its color according to the liquid. So that's why we can say that the ink is soluble in water. Yes, we can't see that the ink is just forming another layer on the water like this. Yes, it is just mixed in water, and just water, the color of the water changes according to the ink. So I think it's clear. Now here we had seen that the oil is insoluble in water and oxygen is soluble in water, and the nitrogen and a methane gas is insoluble in water. So I hope this all is clear to you all. Now let's see a very interesting question. Why does the salt or anything like the salt, lemon juice or oxygen dissolves in water or gets disappeared in water? Why is that? Now for understanding this, let's move on, and now let's see a very interesting thing here. So now let's suppose that this is a glass of water. Here is the glass of water. So this is the glass of water, and now what I am going to do here is that let's take this black color. Let me change my marker here. Let's take this black color and let's represent the water molecule with this black color, and now I'm going to use a blue color for representing the salt molecule. Yes. Now why I am writing here molecules? Now at this level we can say that the salt is just disappear. But if you are going to zoom in a little, or if you are going to go in the microscopic level, what do you going to see that at that time? Let's see that together. So here now let's just when we go in the microscopic level, we will see the molecules. Yes, the molecules. What is the molecule? The molecule are the balls which makes the matter. Anything you can say. Now, the molecules, let's represent the water molecules here. So, let's use the black color. So, do you know that there are some gaps, right? There are some gaps between these molecules. Like this, you can represent the water molecule and so on. I'm not going to draw this all. Okay. So, here we can see some water molecules jiggling around. And now let's put the salt and let's see what happens. When we put the salt inside the water, what happens is that the salt molecules takes up the space between the water molecules. What do you mean by this? Now can you see this? The salt molecules just spread out and takes the places between the molecules of water, as you can see this. So that's how the salt get disappear. Actually, it is not disappearing. It is just occupying the space. The salt molecules are just occupying the space between the water molecules. And if you will just take a glass of water and mark the level of water, and when you pour the salt in it, put the salt in it, what will happen? It will just disappear, and if you will see the level of the water, it doesn't increase. But what about the oil or the rice grains here? And I have not marked the level of water, but as you can see here, of course, it is going to increase, right? Because these are the matter. Matter occupies space. That is the natural thing. So water, can you see this? Water is occupying its own space along with the oil is occupying its own space. But in this case, when the salt is dissolved in water, the water level doesn't increase. That's because the salt is taking up or occupying the space between the molecules. There are some space between the molecules, right? So it is just occupying that space. That's why the water level doesn't increase. So I hope this all is clear to you. And now what was our topic? Sorting the materials according to the solubility. So how do we sort the materials according to the solubility? Yes. So we make two groups, insoluble material and soluble materials. That's how we sort the materials according to the solubility. Now, do you know very interesting thing, a very interesting fun fact about the water, that the water is known as the universal solvent. What do you mean by universal solvent? And why is the water known as universal solvent? Why not the oils or the anything else like the petrol or anything else, lemon juice, anything? That's because the water can dissolve the maximum number of things, and that's why it is known as the universal solvent. So the water, I repeat that the water dissolves the maximum number of things. We can say that the oil dissolves some of the things, but see, all the liquids can dissolve a fixed number of things, right? They can't dissolve all the things in the world. So, like we had seen the water, that it dissolves the salt, sugar, lemon juice, ink, oxygen, carbon dioxide, and so on. But the water doesn't dissolve. The oil, rice grains, and the methane, nitrogen, these all doesn't get dissolved in the water, right? So, here, do you know, I repeat that the water dissolves maximum number of things, and that's why it is known as the universal solvent. I hope it's clear. And now let's talk about a little more about the solutions. So I'm just going to rub this all. Yes. So now we are going to talk about the saturated solution. What do you mean by this saturated solution? It is very interesting. So what happens is that here I again have this glass of water along with the salt. Now let's mix a little more salt to understand this. So now I am just going to again open this cap. And now let's mix the salt again. At this time I'm going to just mix a lot of salt. Okay. And now let's mix it up. Oh wow, what is happening? The salt seems to settle at the bottom. What's that? Earlier the salt was dissolving and now it is not. What is happening? Let's just shake a little. What is happening here? Can you see this? Now let me show you a little closer. Can you see this? That the salt is not dissolving in the water anymore. Now why is that? That's because all of the space between the water molecules is just completed. No more space is left it out and no more salt can enter. And that's why this solution becomes a saturated solution in which any solute is dissolved maximum in the water. Sorry, in any, you can say, solvent. Now this is the saturated solution. As you can see. Let's imagine this with a very interesting real life example. So, do you know a passenger bus, right? So, let's suppose that there are so many people entering in the bus. And let's suppose that there are 50 seats in the bus. Okay, there are 50 seats in the bus. And that one day, there was a very interesting day. All the people was very busy. They want to get their office at as much in the little time as much as possible. So what does they do? The bus start filling up very fastly because many people just enters in the bus. So first the seats just get full up and then some people manage to stand in the bus, and after that the bus is just full. No one can enter in this bus. That's it. And that is which we can relate this to the saturated solution, in which water seems like a bus and the salts are just the passengers. And now when the water is full, no more salt can occupy space because there is no space, right? So that's why the salt starts settling at the bottom, and this is an example of a saturated solution. Now do you know that if I heat this solution a little bit, okay, if I heat this solution, what will happen? I can't show you right now. So what will happen is that this salt which is settling at the bottom, now let me just, yes, so this salt which is settling at the bottom, as you can see, this will dissolve in water. Why is that? That's because we are heating the water.